Hello, I'm going to tell you why I fixed stuff. So today we've got this wood box comptometer. Pretty excited to finally get one of these. This is the first model of the comptometer, and I believe this is also the first mass-produced, marketed calculator to use keys. A bit sticky. The arithmometer that was on the market before this was a slider-based entry. So I believe this is the first one to use keys, and I also believe this is the second, mass-produced marketed calculator behind the arithmometer. So introduced in 1887, and then I think the next one to be marketed was Oedner's arithmometer, starting in 1891. I don't know how exactly this comes apart, but I can see some screws in the register cover here. So one's loose actually. This one's stripped. So not a great start. See if this one will come out. It's also stripped, I think. Yeah. Well, not be much holding this on. Oh, this one feels tight. Maybe this one will come out. There we go. We got one good screw at least. Yeah, that one feels pretty loose. That one's a short one. Probably the wrong screw in there. The other ones are missing. Let's see if this will come out. Doesn't seem like the one. So there's another screw up here somewhere. Oh, the other one's hiding up here. There's one. There we go. So that comes out. See if I can clean this up some more. It's all rusty, and most of these decimal pointers, some of them seem a little bit stiff. The serial number, by the way, you can see there is 719. So I believe this was manufactured in late 1881, and I will show why I believe that in a minute. Not 1881, 1891 is what I should say. 1891. I think it's manufactured in 1881. 1891. So take a look in here. See, it's pretty dirty. Some dirt on the numeral wheels, obviously, because there's no window covering this. Not sure what that is. Oh, it looks like a nest of some sort. Interesting. Remove that. I just should have mentioned that this machine actually does mostly work. So you can enter stuff. However, when you enter a big number like 9 or 8, sometimes the rocking segment gets stuck down and doesn't spring back up. So it's just going to be dirt in the mechanism. You can get this out here. It does clear out just fine. So hopefully all this is going to need is just some cleaning up, and hopefully it should work just fine. So I've played around with this a little bit, probably played around with it a little bit more than I should have before properly cleaning the mechanism, but sometimes I just can't help myself. So take these screws out of this panel in the back, see if this wood panel will come out, get a better look at what's inside. The later comptometers, you take 4 screws out of the bottom, and the whole thing lifts out of the. It doesn't look like the right screw for that. The rest is a machine screw. That's a wood screw. You take 4 screws out of the bottom, and the whole thing lifts out of the case. But this machine does not have any screws in the bottom, so that comes out, and doesn't really get any insights. All I can see in there is just the return springs for the rocking segment. So I think what I'm probably going to do is turn the camera off and just have a nice good look around here. I know that these things have to come off the side, that I'm sure of. So I'll take these guys out of here. There's the release and the tuning knob. This doesn't look like it's in straight. Interesting. whole bottom just fell off. Already, just that off to the side. I don't think that was supposed to happen, so it'll have to be glued back in. At least that will give me some insights, I think, into. I'll take this apart. I don't think this screw is going to play nice with me, so I have to fight with that. Turn this up. The case feels pretty solid, so I'm not that worried about it falling apart on me, but obviously anything this old, you just want to be pretty careful with it. And this screw is not cooperating. See if this one will come out. So that one comes out. So that one's also somewhat stripped, unfortunately. Let's see. This thing just lifts out or what? It just comes out of there. So that's just got a slot in the end, so it just slots onto a little shaft in there. That's out. And looks like someone had a little bit of fun with that piece. It's like they screwed it on a couple different ways before they finally got it right, or maybe this one stripped out and so they rotated it somewhat to put it back on, to get it to stick back on, then one of the screws shipped out again, so see about that. This will come out of here. Actually, these screws are messed up. I guess is expected for something that's old. Just one more, I think, in here. That comes out. And that just has two little pins on it that will index into a little wheel in there, so it's pretty simple so far. So actually this is pretty loose with the case now. See a hole there with no screw in it. I think there's a hole on the other side that did have a screw in it, so let me just carefully set this back down. Yeah, the whole thing is pretty loose now. I'll take out the screw from this side. See if this will just come out of here. Yep. Okay. Alright, so looks like the way this is supposed to come out is, the way we just took it out. The bottom is supposed to stay on, and then you take those two things off the side, then the two screws that are supposed to be on either side. So see, there's a hole there, and then same thing on the other side. So this one had a screw in it, the other side did not have a screw, so that's missing. So let's see if we can find something for that. I'll have to glue the bottom back together. You can see this piece stayed in, the rest fell out, so I'll have to glue that back in. I don't think that's supposed to come out. So yeah, overall, not too bad. Pretty simple once you know what you're doing. You set that off to the side so it doesn't get damaged. And it actually didn't gain us a whole lot of access because see the side here has a solid plate. So this is the release thing. So you can see this guy here will go on that shaft, and then when you rotate it, let's go on. I'll pull that release down, and then you can turn that thing via this guy, which indexes in these two holes here. And you can turn that when that's released. So that's the turn release. Pretty simple. I think I'm going to see how hard or easy it is to take these out. Not sure if anything connects on the bottom. Actually, let's take a look at the bottom. See what that looks like. Okay, that is very different for the later models. So the later models, the key stems run all the way down here, and then they have little pivot things they slot into, so when you push the key down, the whole pivot locks, and the springs on the bottom. But in this one, the springs are on the top, as we saw. So I actually wonder if you can just lift these right off the top then. Let's try that with one of them. Should probably try with this one on the end first. Gotta get what's exactly down there. So that strip just comes right off, and it's a lot of dust, nothing else. Let's try taking off the next one. I'm not too sure about that. I wonder if I have to take this brace off the front here, perhaps. Sure, if anything's attached to that, but yeah, this doesn't. Oh, there it goes. Alright, so yeah, that just lifts out, and you can see the. It's an interesting looking one there. The key stems there. So I guess these just slot into. Just slot through holes there, and that's about it. And then you can see there's a metal strip on the bottom that the springs press into and holds the shafts. And actually looks like they're kind of stamped there to prevent them from popping out. So yeah, that's both the spring retainer and the key stem retainer, this little piece of metal here. Interesting. So, give you a little look at what's down in there. So you can see they just got little D-shaped holes here that those key slots slot into, so they can't rotate, and they just go down through little braces down in the bottom. I'm not sure if you can see that little dusty thing, and then they push on the rockers here. So yeah, pretty simple. So I'm gonna take the rest of these off and start cleaning and see if I can figure out why some of these get stuck when you push a 9. I'm sure it's just, dirt or grease somewhere. See if we can get some of the dirt out of the register there, but I want to see what these guys. Looks like these guys actually do not attach to this piece here, so I might end up taking this piece off. These are the carry inhibits. Oh, I see how that works. So you push it back, and it actually looks like it stays back. I'm not sure if it's supposed to or not. Interesting. That one looks a bit stuck. That one's stuck. So yeah, some sticky stuff. Gonna have to look into that. I don't think it's free, but doesn't want to. No, something else is stopping this. Okay. This is where it's supposed to go. Anyway, nothing to put on with that. So take the rest of these off, and it's about cleaning everything all up. The keystones themselves don't look that bad, really, but there's a bunch of dirt down in the bottom there. So I'll just continue taking these out and see about cleaning everything up, and we can go from there. Alright, so as you can see, I have cleaned up the tops of these guys here. These pieces here had a light coating of surface rust on. I kind of wanted to take them out and, evapor rust them or something, but they're attached to a spring, as you can see here, and kind of concerned with my chances of unattaching and reattaching 130-year-old springs. So since it was just a light coating of surface rust, I just ended up coating the whole thing, all these down in oil. That'll prevent any further rust, and I think that'll be fine. I like that option better than risking trying to unhook and rehook all the springs, because they're 130 years old, and if you break off, the hook on the end of the spring, then you gotta try and fix it, and that risks breaking it more. So I think I'm gonna be fine with that. These guys here are the overshoot protectors. So normally they would be held down like this, or somewhere around in there, by the plate that was over here, this guy. And how they work is, you can see there's a little hook right here, and there's another rocker that runs on the bottom. So these rockers on the top are the drive rockers. So let's see, if I push that down, it drives the wheel forward. There's another rocker down on the bottom, and if I push that down, you'll see that pulls that link there down, which then pulls this to engage with a cage on the wheel here. You can kind of see down there, those little pins. So when this goes down, it goes in between the pins and blocks the wheel from moving anymore. And that rocker on the bottom is pushed by the bottom of the key stem. So the way this works is the cut here, this flat spot, the bottom of that pushes on the top rocker to drive the wheel forward, and then the bottom of the key stem pushes on that rocker on the bottom to prevent overshoot. So as soon as the key gets to the bottom of its stroke, it hits that extra rocker and locks the wheel from turning anymore. So you can't, if you push the 7 key really hard and gave this rocker some momentum, as soon as the 7 key got to the bottom, this would prevent the wheel from potentially overshooting and going past 7 that you pushed on the keyboard. So that's how that works. Like I said, one of these would be held down like that underneath that extra plate. These are the carrying inhibits. I think that this is the only motion they're supposed to have. This one's a little bit sticky yet, but most of them are freeing up. I still have to put some oil on the actual pivot points, but just playing around them a little bit, they actually seem to be freeing up pretty well, so I think those will be fine. Something interesting too that I noticed, these drive rockers are actually 2 pieces. There's the big long stamped piece that has the pivot in the back and then runs all the way up to the front, and then this tooth section is actually a separate piece that is riveted to that stamped steel part. And that's the difference from all the later comptometers, where these rockers were all one single piece with the teeth on the front. I think they were one forged piece, where this is a stamped piece with probably a machined piece on the front here. I think these were machined. So yeah, I cleaned these up, cleaned up the extra pieces down there. There's a little bit of rust on these. I mainly focused on the areas where the keys go through. I'm going to put a light coating of grease on these and a light coating of grease on that, so the keys slide through there. I have some lubrication, and then once all the keys are back in, then I'm going to focus more on the front here, because I can do that with the keys in, and it'll be a little bit easier actually to, you can push the one key and drive the register forward as you clean around the digit wheels. I think that my theory about these just being, sticky on dry grease is, I think, correct, because I'm not going to push 9 because without these in, sometimes these pop up too far. But this seems to be springing up a lot faster than I just oiled this first one here a little bit. Cleaned and oiled that first one. Started on the second one, then I decided to put the keyboard, get this all cleaned up to put the keyboard back in the first, and then finish cleaning on the register. So I just kind of wanted to show a little bit about how this works. It's really pretty simple. And then the carries are really pretty basic. There's a snail cam on the inside of the wheel in there, and this piece here has a little roller that rides on that. So you see, as soon as I drive this forward, you'll see that this moves out because it's riding on that snail cam. And then once this gets to 9, this thing falls off the end of the snail cam and springs back in, pushing this one position forward. So pretty basic carry mechanism on this, and that's the reason why you, on these early ones, you can only push one key at a time, because there's nothing. So if I push 2 keys in separate columns, then there's nothing that prevents this carry from happening at the same time as this is being driven by the rocker, so you lose a carry then at that point. So if I push, say, this has, say, 4 and 5 in here, and I push 9, then this one will carry over to here at the same time as I'm pushing that key. So, this will be driving a carry at the same time this is driving it, and then the carry gets, accounted for by the drive from this. So basically you lose the carry there. On the Model A and later, they call the duplex comptometers, they fixed that by making it so that the carry is held if the key in the particular column is being pushed. So it waits until this rocker returns back up to the top, and then re-enables the carry to carry over. But on this machine they didn't have that yet, so you only push one key at a time, which is going to make multiplication and division pretty tedious, but I guess still better than doing it by hand. So yeah, I'm going to grease up these rockers here, put the keys back in, probably clean and grease those as well, and then I'll move on to cleaning the register, and hopefully that'll be about it for this. As far as the rust on these side plates, I'm just going to probably go over them with like a little bit of Scotch Brite or something just to get the scaly stuff off, and then I'll just put a light coating of oil all over everything to prevent further rust. Not going to go overboard. Just want to make sure that it doesn't, rust anymore. But if it took this long, 130 years to get to the state that it's in, I'm really not too concerned with it. Probably take 4,000 years for any sort of actual weakening of this flame. This is, decently thick steel here. But I'm going to put some oil on everything just to make sure that it doesn't rust any further. And I think that'll be fine. I'm just going to show this real quick. This is the bottom of the machine, and these are those pieces I was talking about. These are the basically the stop overshoot protector lever things. So the bottom of the key stems push on these and pull them down like that, and then this wire here is what goes up and is attached to that peg on the top to pull the stop detent into the wheel. That's when I heard that these are just square tubing, which is kind of interesting. Usually you're used to seeing everything as some kind of custom stamping or whatever, but these are just square steel tubing, and they cut out the end there for the one key to stick through. So I thought that was kind of interesting. So more like kind of thing you expect to see in a prototype, not really a production machine, but I guess it's what they did, and it works. So I thought that was kind of interesting. And also you can see that these connector links here are just attached on with some wire, so they loop around and then they're just wired in place. Also, it's not something you're used to seeing, so just wanted to show that a little bit. But yeah, pretty much got this mostly cleaned up, mostly reassembled. Flip this back down, perhaps. And I guess we can do a little test now. Now they got everything together. Actually should clear this out. Where's my clear? So we'll clear this out. So that's cleared out. So frame here. Fit all the keys. something's not right here. These should be 9s. Let's try clearing it out again. So for sure we are clear. So we hit all the keys, it should result in 4 all 9s and a 5. So let's see. And you can do intermediate results too, because like if I do just this column, there should be 4 then a 5, right? Yeah, so that's right. So now if I enter all this column, the 4 should move over to here, and there should be a 9. So that worked. That worked. I don't know what happened that first time, but it seems to be working now. Keep an eye on that, I guess. So now that's what we expect, 4 on a 9 and then a 5. So yeah, not quite sure what happened that first time. I ended up with an extra 1 somehow. Interesting. Make sure that's going to be reliable going forward. We can also do like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. And that is correct, 2 through 0. That is correct. So yeah, like I said, not quite sure what happened that first time, but alright, so as you can see, the digit wheel's cleaned up pretty nice, nice and readable now. Before, some of them were pretty dirty with grease and stuff, but look fine now. So I'll have to clean up the keycaps. Hopefully those will get somewhat better. Clean all the dust out from these key plates for the most part. There's a little bit of dirt here yet, but I'm just gonna leave that there. Got all like the heavy dust and everything else, so they look fine, I think. Maybe a little bit more cleaning on the back section there, but yeah. So far so good. Everything is moving a lot freer now. The issue that we had with these things getting stuck at 9 is resolved. It was just oil dried grease in there. So that seems to be fine now. So yeah, I have to clean up the pivot points on the back of these shafts, get clean oil those, and like I said, clean up the keycaps, but I think we're getting pretty much done, to be honest. I did put this piece in Evaporust. When I took a look at it, it was more rust than dirt on it, so I put it in Evaporust and it's fine now. It pulls down the front of the keys. Also is the stop point for the locking segments that come up when they stop against this. And those detent fingers that go into the wheel also stop against this as the top detent. So this does multiple purposes, but also it holds the sides of the case together somewhat as well. The construction of this is kind of reminding me of the Monroe Model G and before, where it's mostly a sheet metal case with some random cast pieces holding it together. There's one here and there's another one back here that these things screw to. And we got some shafts and stuff that go through, hold it together. Something else that I did notice is, if you can see, but there's actually a screw head broken off right here. Not quite sure that happened. I didn't find I didn't find the screw head in the bottom of the box, so not sure if that's recent or old. Kind of hard to tell. I don't think I can get this screw out of there, so I don't think I can replace that. So for now, I'm not really going to worry about it. This is held, like it's held together with this, held together here. I think this held together here and then there. So it's not going to come apart. I'm not worried about that. But yeah, it's just kind of interesting. If I could get that out, I maybe could replace that, but I don't think it's going to come out. So I'm just going to leave it alone rather than risk damage trying to figure out how to get that out of there. But yeah, so anyway, I think coming along so far, so good. I kind of wanted to show the clearing on this. So the shaft runs all the way through the middle of the wheels for the clearing, and it has little pins on it. I'm not sure if you can see, but right down in there is one little pin right there. And those pins grab ratchets on the inside of these wheels, and the ratchet is right here. So I'm just moving the ratchet there. So basically what happens is when you're operating the machine, the wheel spins this way, which means that the ratchet is able to click past that pin. However, when the shaft spins, that pin will come up and grab that ratchet and pull the wheel all the way around till it gets to zero, at which point the shaft, because of its cam on the end, locks into the lock and stops everything at zero. Just want to show that inside the wheel here, there's a little ratchet that sticks out of the wheel, kind of little lamp thing right there. Hopefully the camera is focused on that. And that's how the clearing works. So when the wheel is being driven, it operates such that this will spin around and click past that pin. But when you're doing the clearing, the pin catches that ratchet and pulls everything to zero. Just kind of wanted to show that. And you can also see here is the edge of the snail cam, and then this thing right here, as you can see, moves if I wiggle this. That's the cam follower that rides on that snail cam for the clearing. And of course, once this gets all the way out, it'll click past a pin on the cage in the next wheel, and then push it forward once it's released to the next position. So, yeah, pretty basic mechanism, really. Once they went to the Model A with the duplex, this got a lot more complicated. But this one's pretty simple. Like on the Model A, they have an extra shaft with extra wheels down here that have a spring-loaded cam on there with catches on it, so that when a carrier it needs to be affected, it releases that spring-loaded cam, and the cam spins around and the parts on the cam cause the carrier to happen. And it's a lot more complicated than this is, but this is pretty basic. I wanted to show that. So as far as the case is concerned, let's move this tripod back up here. I did glue the case back together. It's kind of weird, honestly, the way that they built the case. Get that. So, if you look at the case, it has it has these two thicker pieces and then one thin piece in the middle. But the thin piece, it looks like, you can see like here, like they plunge cut a saw almost to the point of cutting these strips off the end, and it's kind of left that little piece of wood there holding it together. I have no idea what the purpose of that is, why they have these slots here, or why they didn't just make the bottom one solid piece. Because this piece is, glued or nailed or whatever to the other piece. So, like, it's not like this can come out for servicing or anything. Like, there's no screws or anything to take it out. It's permanently attached, or it's supposed to be. You can see that there's no screws or anything holding that in. It's just glued in. So, what the idea was there, I'm not entirely sure. You can see here where they had to chip away some of the box to make it fit with the mechanism there. It's kind of interesting. But yeah, so this is solid now, so that should be fine. The actual case was pretty solid anyway, just the bottom fell out for some reason. You can see somebody had a little bit of fun drilling the holes for the clearing knob and the release. It's like they started with those ones and then gave up and rotated a little bit and made some new ones. And then this one, I'm guessing it stripped out at some point. Like you can see the thing is broken out there, so they had to rotate it and then make new holes, and looks like that one is failing too, so it's kind of interesting, but yeah. I'm not going to try and make new holes. This thing was held on pretty solidly when I got it, so I'm pretty sure it's going to be fine just reusing the holes it was in. And I feel like if I tried to make, a hole here, and try to make one there, it would just make the situation worse. I'll just weaken that wood around there even more. So I'm just going to reuse the holes it was in, and should be fine. I mean, it's not like this thing's going to be, used, regularly or anything. It's more of a, decoration. just play with it now and again, but as far as actual use, which I'll show when I demonstrate this, this is not as, I don't want to say not as useful, but not as easy to use as the later comptometers because you only push one key at a time. So, doing multiplication and division on this is not easiest. And, even for addition, with a later comptometer, the trained operators would just, touch type on the keyboard, not even look at it, just push all the keys they needed to. But on this one, you have to go one key at a time, so it would definitely slow you down there. So, yeah, I think I am just about ready to put this back together, and then we can do a little demo. So as it turns out, the lever release to release the clearing knob is more than just that. It actually releases the detents from the wheels. So watch this piece right here. As I push that, you'll see that pops out. So that releases the detents from the wheel. So as you're turning this, it's not constantly clicking past detents. That was kind of interesting. That also gets released when you push a key. So as soon as I start pushing the key down, it releases that. So that's just there to lock these wheels from moving when they're not actually being driven by anything. So when you push a key, it releases that so the wheel can spin, and when you start the clearing, it releases all of them so that the all the wheels can spin. Because I was looking at that, I was trying to understand why they had that release instead of just having some kind of detent on that wheel, but that's why, because it releases all the those locks in there as well. Alright, so I went and I cleaned up all the keycaps, and then I cleaned up pretty well, actually. Some of them, the numbers are a little worn off, like here, it's missing a little tongue there on the 1. Like this one, the 7's a little bit faint, but, and this one too, a little bit faint, but I think they cleaned up pretty well. They look pretty decent. Other than that, you have to remember this is 130 years old, so expect some wear. Yeah, I'm pretty satisfied with that. The metal pieces here are just corroded, I think, so maybe you could go through and shine those up, but I'd be worried about damaging the center pieces, so I'm just going to leave those as is. I mean, all the keys are pretty much readable, except maybe that one's a little bit hard to read, but it's okay. So yeah, this piece, I had that in evaporust, that cleaned up pretty well. Only a little tiny patch of rust there, but the evaporust supposedly, whatever, this is not some other brand. This is this stuff. It says something about it puts a coating on, so it's not supposed to rust any further. So I'm not too worried about those two little spotches there. Decimal pointers, a little bit stiff, but they do work. None of them are, frozen in place. Like I think this one was frozen in place, and now it's usable. So yeah, let's do a little demo. So we already showed addition. Let's show subtraction with these carry inhibitors. So say I have something like 45 in the register, and I wanted to subtract 7. Well, if I just push the 7 key, that's going to add 7, so I don't want to do that. I have to use the little keys. Now, because 7 is larger than 5, I actually have to enter 0, 7 on the little keys. But it's always 1 less than the number you want to enter, so I actually enter 0, 6 on the little keys. So to do that, I will hold up the carry inhibit left of the leftmost column I'm entering in, which is this one. So 0, 6, and there we go, 38. I have subtracted 7 from 45. And it's really as simple as that. If they didn't have these, you'd have to enter all the zeros and then 6, and you still end up with a 1 over there. On the Burroughs clone of the comptometer, I don't want to call it a clone because they used a different mechanism, but on the Burroughs comptometer, they didn't have these per column. They only had 1 in the last column. So on the Burroughs machine, you would always have to enter all the zeros and just hold the carry inhibit in the last column. It's kind of getting off tangent, but just something I wanted to mention. On the comptometer, they always have carry inhibits for every column. Except for the very first examples of these, they didn't have carry inhibits, but I think they added those pretty soon after they were on the market. So we can clear that out. Clears out nicely. So let's do multiplication. Why not? This is going to be slow, but it's always on these machines. So I'm going to do 625 times 625. I'm going to have to enter 625 5 times over here. Now normally you could just press all the keys at once, but you can't. So we have to do 6 5 times, then 2 5 times, then 5 5 times. So let's try it. And hopefully I don't lose count along the way. Because we're going to have to do it 5 times here, then 2 times, then 6 times. So let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Alright, so that's 625 times 5, which is 3125. So now we want to do 625 2 times here. So 1, 2, 1, 2, 1, 2. And now we want to do 625. Did I do that wrong? I think I did that wrong. I was supposed to do it here 2 times. Let's start over. I think I messed up. Alright, let's try that again. We can do here, here, then here, then here. Alright, so 1, 2, 3, 4. Alright, so now we want to move over one place. It's easier to keep track when you hold it on your fingers, and you can't do that here. So we're going to move over one place and do it 2 times. Alright, and then we want to move over here and do it 6 times. There we go, that's correct. 390,625 is the correct answer. So that's how you do multiplication on these wood box comptometers. Pretty slow, probably slower than doing it by hand. It's a little bit hard to keep track of. Maybe you want to use these as like keep track of where you start and then move over one column. That's why I got confused at first initially, because like I said, usually on the comptometers you hold your fingers like this, and then it's easy to just slide over one and then slide over one and then keep going as you go along. But on this one you can't do that. I mean, I guess you could do it and then just push this finger, then this finger, then that finger. So maybe you could do it that way. But that's what messed me up. I accidentally moved over too many columns initially and then got confused. But yeah, it does work if you know how to do it. Pay attention. Let's do a division. See if I can mess this one up too. So 355. We'll divide by 113. So we do 112 on the small digit because remember, it's always 1 less than what you want to do. And we do not use the carry inhibits for division. So let's get started. So first we look here, there's a 0, so we ignore that. Then we look at 355 is larger than 113, so we'll enter it once. That's still larger. That's still larger. 16 is smaller, so we move over 1, so moving over to here. And we've got 160, that's larger, so we enter it once. Actually, we look at this first. That's a 0, so we do nothing. We got the 160, so we enter it once. Now we've got 47, that's smaller, so we move over 1 position again. Now we're in this column. We've got a 0 here, so we ignore that. We've got 470, so we enter it once. 357 is still larger. 244 is still larger. 131 is still larger. Alright, we've got 18, that's smaller, so we move over again. We've got a 0, so we ignore that. We've got 180, so we enter it once since that's larger. Now we've got 67, that's smaller, so we move over again now. Now we've got a 0, so we ignore that. We've got 670, so we enter it once. 557 is larger. 444 is larger. 331 is larger. 218 is larger. 105 is smaller, so we have to move over again. Now we've got a 1 here, so we have to enter it once to start with. It's still a 1, so we've entered it once, we've got a 1 here. That's, since they're equal, we move on to looking at this now. 937 is larger, so we continue. 824 is larger. 711 is larger. 598 is larger. 45 is larger. 372 is larger. 59 is larger. 146 is larger. And that's it. 33 is smaller, and we run out of machines, so we stop. So now we set our decimal point right there, 3.14159, and then this is the remainder. So this is the actual answer, 3.14159, which is correct, and then a remainder of 33. So yeah, that worked. I didn't mess that up. Again, it's a lot slower than the later versions, but I still think that's a lot easier than doing long division by hand. So the machine would definitely have an advantage there. I have no idea how much these cost. I have no idea how much you would have to save on your business back in 1891 to make it worth it to buy one of these. Like I said, they made this up until 1904, or not, 1903. Some dirt there, my paper towel. They made this up until 1903, and they only sold a little over 6,000 of them. So I'm guessing they were pretty expensive back in the day, but I don't know what the actual price was. But yeah, anyway, I think this came out just fine. It looks, to me, it looks fine. A couple of these boards here have a little bit of the lacquer remaining on them. Some of them are a little bit shiny. The rest are, the lacquer is mostly worn off. At least the shine is worn off and it's just dull. But honestly, I think it looks okay. I could probably maybe go through and clean a little bit of this dirt up, but you know, it's 130 years old, so I'm okay with it, you know, looking its age, as long as it doesn't look, you know, as dirty as it was. You know, there was a good layer of dirt and dust on these boards. I wanted to get that cleaned off, but a little bit, you know, of darkening here and there, you know, just shows its age, and I'm okay with that. Yeah. So I think that's about it for this video. Pretty satisfied how this came out. Finally glad to have one of these machines. They're pretty cool. I do like these dials here. Kind of wish they would have continued to use them, but I think they're a little bit harder to read than the later ones in some of the digits, but I think they look a lot cooler. Definitely makes it look older than like the Model A, which had its plastic. I think they were celluloid or whatever. I think that these ones look cooler, but like I said, they're a little bit harder to read, the reflection, but something they look cool. Anyway, so that's the end of this video, and thank you for watching.